Hi guys. Okay, so this video is for my 8th grade pre-algebra class. If you look on your lesson plans for today, I know I put February 17th because I had a overworked, distracted teacher moment and didn't know what day it was. So this is actually for today, the 18th, Thursday. We're going to finish the homework assignment for section 4.3. So I'm going to work through all these problems. I would like for you guys, based on the work that we did in class yesterday, before you watch this video, go ahead and look at the assignment. It's numbers 16 through 36, only the even problems on page 147. And do your best possible work. Like do the best that you can on those and give them a try. And then come back and watch the video, see the work through and see how you did. Okay, let's get through these because that's all we're doing today. Let me flip my screen and get my face out of the way. I didn't know that was still showing. Actually, it might still be for you guys. If so, I'm sorry if I write under myself. Okay, so this is section 4. It's really bad glare. 4.3, page 147, numbers 16 through 36 even, because we did 2 through 14 yesterday in class. Okay, so number 16 through 20 actually finished that section B exercises using prime factorization to find the greatest common factor of each set of numbers. Again, this should be review for most everyone, but we just wanted to make sure it was still forefront in everybody's mind before we move into the actual algebra portion of this chapter. So for number 16, I'm just going to work these out as the instructions say using prime factorizations. So 16 has 81 and 189. 189. Okay, so, and I would take kind of a wild stab at the fact that possibly 9 is probably our prime factor. I like to guess, that's just me, and then work it out and see how close I am to being right. Simply because we know that 9 times 9 is 81, and we know that 9 divides evenly into 189 because 1 plus 8 is 9, 9 plus 9 is 18, so 9 goes into that. But let's see how we did. Okay, so gonna pull out a 3. Why would I do that? Doing it the hard way, I guess. Okay, so 3 goes into 8 2 times with 2 left over. And that leaves you with 27. There we go. All right, then 27 is 3 divided by 9. And then 9 is 3 times 3. So our 81 equals 3 times 3 times 3 times 3. Okay, now 189. Again, I'm going to go ahead and try 3. 3 goes into 18 6 times, and then 3 goes into 9 3 times. So we have 63. Okay, so 3 goes into 63 21 times. 3 goes into 21. 3 times 7. So our prime factorization for 189 is 3 times 3 times 3 times 7. So no, I was sort of close, but not really. It's actually larger than 9. It looks like our prime factorization here is 3 times 3 times 3. Also, you can write that as 3 cubed, which is 27. Excuse me. Okay, so that's our greatest common factor between these two numbers. All right, so for number 18, we have 12, 18, and 24. And those are all small numbers, so it's pretty easy to guess what your greatest common factor will be, since that's 6 times 2, 6 times 3, and 6 times 4. But let's work it out. Remember, this works no matter how many numbers you're comparing. So that's 2 times 6. I don't know why I'm doing this with me. Y'all just bear with me. And then 6, so 2 is prime. And then 6, it's 2 times 3, and we're done. 18, 9 becomes 3 times 3, and then we're done. 12 becomes 2 times 6, which we have to go one more level to 2 times 3. And then we have all of our primes. Okay, so 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. And then 24 is 2 times 2 times 2 times 3. All right, so we have, why did I do that? A 2, one, at least 1 2 in each one, but we don't have any more 2s in 18. So those are now invalid. We're not going to be using those. We also know that we have a 3 in each of these, which means that one is extra because it's the only one that has more than 1 3. And therefore, just look at one number. So I'm going to pick the top one because we've already circled which one's the same in each one. So now you can ignore the other two, and you see that you've circled a 2 and a 3. And when you multiply those together, you get 6, which is the greatest common factor of these three numbers. Okay, 18. Wait, wasn't that 18? Yep. Yay, virtual learning. Okay, number 20. Okay, 20 gives us 27, 45, and 54. And this one I'm going to say is definitely 9 because it divides evenly into all of those. Let's see, 3 times, 5 times, 6 times. So probably going to be good with that one. Okay. I know y'all are thinking she has the teacher's version. She has the answers right in front of her. Y'all, I have to look for those. They put them in a different color, and it's like my eyes don't even see them unless I go looking for them. And y'all know my brain is weird, so usually I forget to go looking until after I've worked the problem with you. Okay, so 27 we've worked out. It's 3 times 9, and then 9 breaks down into the 2 prime or 3, the prime number 3 2 times. Okay, so we're left with 3 times 3 times 3. 45, I would start with 5, right? 5 times 9. And then 9 is 3 and 3. And we're done. There's our prime factorization for 45. And then 54 is even. So I'm going to start with a 2. 2 goes into 5 2 times. 2 goes into 14, 27, or 7 times, so 27. Then that's 3 and 9. And then 3 and 3. So lay them all out so you get a very clear idea of what you're working with. Remember, only take shortcuts if your brain functions in a way that you don't miss the details, because otherwise you're going to miss something silly and you're going to feel silly even though you're not. So just work it all out like you're supposed to. Okay, so we've got all of our prime factorization out for 27, 45, and 54. So let's find our common factors. So we have a 1, 3 in each. There's no 2 except for that 54. So I would just mark through that one. Excuse me. And then also looks like we have another 3 in each of them. But then 27 and 54 have a 3, but 45 does not. So those are not needed. And then 45 has that 5, which nobody else has. So those are not needed. Okay, so now look at one of them, just one. I noticed this sort of confusing some of you guys yesterday. So once you have determined what your common factors are between these different prime factorizations, ignore the other numbers and just pick one because it's the same in each one. So therefore, we see from this that the common factors between all three of these is 2 3s, which equals 9, which is our greatest common factor. Okay, number 22. Number 22. Okay, this is where we move into the fun ones where we play with variables. So for 22 through 26, we're using prime factorizations to find the greatest common factor of expressions. So remember, an expression is a combination of constants, variables with various exponents. And then we look for like terms when we combine, when we're working on equations. In this case, you're actually finding the like term that exists in all of the expressions. It's pretty much what we're doing when we find the greatest common factor. So let's go ahead and break these down. So in this case, for 22, we're not working with any constants or what we would call coefficients. So just have variables. So our first one is a squared b to the power of 5. And then our second one is a cubed b. Okay, so a lot of you will be able to see this and recognize the fact that you can just pull out the lowest exponent of a and the lowest exponent of b, and there's your greatest common factor. If you are there, awesome, congratulations. You big brain person. you understand how these work together, and that will help you when we get farther along in algebra. But right now I'm just teaching you guys how to see that. So still go ahead and work it out. Take it a variable at a time. So in this case, I'm going to start with a. So I'm going to break a down into a times a, and then b. You can do this different ways. So you can take out one b, so b times b to the 4th is b to the 5th. And then you can bring it down, take out another b, and you end up with b to the 3rd. This is a long way, super long way. If y'all don't know where I'm going here, then just ignore it. So you can break that down until you end up with all of your single variables with the exponent of 1, which we don't show, right? And then at the end, you get a times b times b, 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 b. 1, 2, 3, 4, 5. All right, it's the same thing. I just did it a super long way, but pretty much all you're doing, if you look back up here, is you're writing your a multiplied times itself as many times as you're given in the exponent. And then you're taking b and multiplying it by itself, however many times your exponent is here, which is 5. So when you look back down here, you see that I have 2 a's and I have 5 b's. That's all you're doing. All you're doing when you have variables and you're trying to find your prime factorization is I'm just doing a times b, 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 until I get to 5. Okay. So that's our prime factorization for a squared times b to the 5th. Okay, so let's go ahead and do this here, and we're just going to break down the prime here. I'm going to do it like I normally would, like I did it in class yesterday. This is just a times a. There's 3 a's times b, just 1 b. All right, but set that up exactly like we did with when we were working with numbers, with integers. So a squared b to the 5th equals a times a b, and then a cubed b is a times a times a times b. All right, so here you can see that we have an a in both. We have 2 a's in both, but that's it. For the first one, we only have 2 a's, so I would just mark through this one. And then we have 1 b in both, and the rest we do not have in the second number. And so then just, in this case, it's smaller. I'm gonna look at my bottom one. Just look at 1 and pull out what you have here. So we have a times b, which simplifies to a squared b. And that is our greatest common factor. All right, so let me show you this the way I sort of mentioned at the very beginning. Let me show you this a different way. All right, I have a squared b to the fifth, and then I have I lost track of where I was, a cubed b. All right, so I'm going to look at my two a's. How many, excuse me, what's the lowest lowest exponent for my a variables? And you find that it is a squared. So a squared exists in both. Now I'm going to look at my b's here and here. Of b to the power 5 and b, which one has the lowest exponent? In this case, it's, remember, anything that doesn't show you the exponent, that is an assumed exponent of 1. Therefore, I have just b. So I'm going to put that one down in my greatest common factor. See how those match? That will always work. Always. Okay. So that's why when I worked with the variables in class yesterday, I didn't do the whole prime factorization of the variables. I just took apart all of those variables to each of their exponents. I broke them up like a squared was a times a, and I put them at the bottom where we compared our prime factorization. But essentially, you can do what I just did and look at all your a's, and whichever one has the lowest exponent, that's your common. It's your greatest common factor of that variable. Then you look at your b's, which one has the lowest exponent? That's your greatest common factor. Now, keep in mind with that, if you have like, let's stick a c squared on the end of this one, but there is no c over here, then there is no c in your greatest common factor. Just ignore it. Okay. All right, let's move on through these. I'm taking too long. 24. So number 24, we have 4. Oh my gosh, I can hardly see this. J to the 5th times g cubed. Okay, so j, why do I gotta use these crazy letters? J to the 5th, g cubed. And then we have 6, j to the 4th, h to the 3rd. All right. Okay, here's a good example of what I was just talking about. Okay, so for right now, ignore the variables. Just work on the coefficients. So 4 breaks down into 2 times 2, and we're done. 6 breaks up into 2 times 3, and we're done. Okay, so we've done those. When you do that, you don't even have to put them next to each other. You know that 2 is the greatest common factor between these two. Okay, now let's look at our variables. We have a j to the 5th here, a j to the 4th here. Which one has the lowest exponent, the smallest exponent, right? It's j to the power 4. So that is our greatest common factor, j to the 4th. Okay, what about g cubed? There is no g cubed here in the 6j to the 4th h cubed. So that is not a common factor. Now let's come over here and look at this h cubed. Well, h cubed is not in our first expression. Therefore, that is also not going to be part of our greatest common factor. So our greatest common factor here is 2j to the 4th, or to the power of 4. You can say that either way. All right. Does that make sense? I hope that makes sense to everybody. If not, write a note. Have me go through this some more when we get back in class together. Let's move on to number 26. 26 is 10 r cubed s squared t, 25 r squared s cubed, and 40 s squared t squared. Right? I think I wrote that down right. 10, 25, 40. Okay. All right, so let's go ahead and do the prime factorization for our coefficients, and then we'll look at our variables. All right, so 10 breaks down into 2 and 5. That's done. 25 breaks down into 5. Why did I put a 2? Meriwether, get off my computer screen. Cat. Oh, sorry. Okay, 25 breaks down into 5 and 5. Done. And then 40 is a little crazier. So we have 2 and then 20, and then we have a 4 and a 5, and then we have a 2 and a 2. So we have 2, 2, 2, 5. Okay. So now let's look at our, well, that's up to you guys. If you want, you can go ahead and pick your coefficient. I'm just going to leave those for right now. I want to look at my variables. So I have a r cubed, an r squared, and I have no r. So r is not part of our greatest common factor. All right, so let's look at s. I have s squared, I have s cubed, and I have s squared. What's my smallest s? Well, it's s squared. So whichever, they're identical. And then let's look at the t. We have a t, but then in our 25, we have no t. So that tells you right now, there is no t in our greatest common factor. So the only thing we have a check mark over is s squared, which means that in our greatest common factor, the only variable involved is the s squared. So let's go back and look at our coefficients. We have a 2 and a 5, a 5 and a 5, and then we have a bunch of 2s and a 5. But it looks like the only common factor is just this 5. So our greatest common factor here is 5s squared. Is that right? That is right. Thank goodness, because now I'm recorded doing it. I better know how to do this. Okay, so yeah, so that's our greatest common factor. 20. Okay, so now we're moving on to asking, is each pair of numbers relatively prime? So remember, when two numbers are relatively prime, that means that the only greatest common factor between the two of them is 1. So it means that they don't share any other factors other than 1. So they are prime relative to each other. 28. Quit. Oh, cat just attacked my foot. She's mad I kicked her off my desk. All right, so it's 14 and 15. Are these Meriwether? I swear. You cat. Oh. 14 and 15 relatively prime. Well, hopefully it's pretty easy to see that this is a yes, but we can work it out. This is how we prove it. 14, let's just work through our primes here, is 2 and 7. You cannot, oh wait, and that's it. You can also work this out when we make the list of factors. Excuse me, especially with this being so small, such small numbers, but still, I'm just going to work through it this way. And this one's 3 and 5. Well, there is nothing common between 2, 7, 3, and 5. Therefore, these are relatively prime to each other. All right, and then the last one, we'll look at number 30. 30 is a little more complicated because we have bigger numbers, 27 and 40. So are these two relatively prime? So let's look at 27 is all about the 3s, right? It's 3 times 9, 3 times 3. And you can determine that this is most likely relatively prime because in no way does 3 ever go into 40. But again, we want to prove it. So this is 2 and 20, 4 and 5, 2 and 2. And so here you see that you have 3, 3, and 3, and there is no 3 over here. Therefore, these two are relatively prime. Okay. So let's do our last section of greatest common factor exercises, number 32, 34, and 36. So in this case, they ask, find the greatest common factor of these numbers given in factored form. Why they thought these were hard, I don't know, but these are supposed to be the hard ones. Y'all got this. Okay, these are just the factors. Look at 2 times 3 squared times 11, and 3 times 5 times 11 squared. Okay, so it's up to you guys how you want to do it. You can either see that again, look at the variable, look at the exponents. First off, look at a 2. Is there a 2 in both of these? No, there's not, so you can cross that one out. Then look at your 3's. Of your 3 squared and your 3, which one has the smallest exponent? Well, it's this guy, because it's the exponent of 1, because it's just 3. There's only one of them. What about 11? We have an 11 here, and we have an 11 squared here. Which one has the smallest exponent? It's the 1 by itself with no listed exponent, so it's 1. And then there's a 5 over here, but it does not exist in the first number, so that one is not part of our greatest common factor. Therefore, look at the ones you put check marks over, and your greatest common factor is 3 with no exponent and 11 with no exponent. And then when you solve that, you get that your greatest common factor is 33. Easy enough, right? Hope so. If not, don't feel bad. You just need to let me know. We'll do more practice so you can get more comfortable with these different processes. Okay, so 34 gives us 3 times 5 times 2 squared. Oh, and wait a minute, what? 3? Oh, I see. I missed a comma. Y'all, I got to get reading glasses. This is ridiculous. 3 times 5, and then 2 squared times 5. And 2 cubed times 3. All right. So what do we have? In the first one, we have a 3. But there's no 3 in the second number. So just mark through all your 3's. There's no 3 in your greatest common factor. Okay, so let's look at 5. We have a 5 in the first one. We have a 5 in the second one. Okay, but then we have no 5 in the third one, so we can't use these either. Well, we just marked out our first number. So what is the greatest common factor between these 3 numbers? If we just eliminated all the factorization of the first number, I don't think I said that right, but you know what I mean, right? Well, remember, if there is not a prime factor that is common between all of your numbers, then your greatest common factor is 1. Which means what? What are these numbers? They are what to each other? These numbers are, or what? Relatively prime, right? By definition. Okay, last one. Let's get this over with. 36. 36 is 2 cubed times 5 squared. Times 11. And then 2 squared times 5 times 7 squared. And 2 to the power 4 times 5 cubed times 7. Okay. Well, we definitely have some sort of greatest common factor besides 1, because we have a 2 in each of these. We have 2 cubed, 2 squared, and 2 to the 4th. Which one has the smallest exponent? 2 squared. So 2 squared is going to be in our greatest common factor. All right, now let's look at 5. We have a 5 squared. We have a regular, just 5 by itself, so 5 to the 1, and then 5 cubed. Which one has the smallest exponent? This guy. So we have 5. And then we have 11 in the first one, but it's not in anywhere else, so that's unnecessary. And also the first number does not have a 7. So that means that these two also are not going to be part of our greatest common factor. So I think we've got it. We have 2 squared times 5. So that becomes 4 times 5. Therefore, our greatest common factor is 20. Okay. All right. Well, I hope this makes pretty good sense to all of you. I feel like it shouldn't be anything too new. We're just coming at things from sort of different directions. So if you have any questions, jot them down while you watch this video, and then I want you to bring them to class with you so we can discuss them and I can make sure everybody feels comfortable with this. Otherwise, we're done. So good luck, have fun. I know ice is not nearly as fun to play in as snow, but I look forward to seeing you guys again soon. Thanks. Bye.